In this question, what we are given is a histogram which the heights of each bar. Like here, the height of this bar is 2, 1, 5, 6, 2, 3, like that. And we need to find the maximum area of any rectangle that is possible. So here we could have a lot of rectangles, like we could have 2 as a rectangle, only 1 as a rectangle, 1 and whole, this is a rectangle, this could be a rectangle, this including only 5 could be a rectangle, including only 2 could be a rectangle, this whole could be a rectangle. So we just need to find the rectangle which would be having the maximum area. Okay, so how we would be going? Suppose we are standing at 2 and let's just include 2. And what is the maximum area we could have including 2? Only 2, because we are not having any bar which is having height of 2 beside it, right? So we could have only 2 here. If now I am standing at 1, what can I see? That I can have this width with 1 and this as well. So I could have total of 1, 2, 3, 4, 5, 6 units of width and height of 1. So its area would be 6 into 1, that is 6. Okay, let's go. Now let's include 5 as well. 5. What could be the maximum area including 5? I could have here, we don't have anything left side at the left side, so only this could be the max. This could be the area. So its width is 2 and the height is 5. That's why the area would be 10. Okay, if we go with 6, we don't have anything up to a height of 6 before and up to a height of 6 after. So we could have only this 6 as a rectangle. So 6 into 1, that is also 6. Okay, so let's have 2. Let's include 2, right? So at right, we can have 3 as well, this width. We can have this, but not above this, because it's having a height of 1. It is lesser than 2. So we could have this as a rectangle. So its length is 1, 2, 3, means width, 3 width, and height is 2. No, the length is 1, 2, 3, 4. It's 4. 4 into the height is 2. That is 8. And for this 3, if we include this bar, then we don't have anything that is left to 3 and that is right to 3. So we can have a rectangle. This is the rectangle and its height is 3 and the width is 1. So 3. So what's the maximum area we could get? That is 6, 10, 6, 8, 3. So 10 is the maximum area we could get. So how we have decided the width of any rectangle? Like suppose if we calculate for 5, how we have decided that its width would be 2 only, right? So here before 5 we have found bar 1, right? So we can not go above 5 because we don't have any bar here. So we found that 1 is the bar which is lesser than 5 to the left of 5, right? And to the right of 5 we found that 2 is the bar which is having lesser height than 5. So I cannot go beyond 6 here and I cannot go beyond 5 here. So I can only go till here, right, and till here. What we have observed, that I just need to know the bar which is having lesser height than the current bar. For 5, the lesser height, then the lesser height of the bar is 2, which is present at 4. And for 5, the bar which is having the lesser height to the left of it is 1. So the 2's position is at 4, right, and the 1 position is at 1 only. So I can find the width of it by just subtracting their positions. 4 minus 1, that is distance between these two, and minus 1 would be the width, that is 2. That is the width of this rectangle, right? So to find the next smaller and previous smaller, I will tell you that how we can find the previous smaller element and the next smaller element. But for now, just suppose that we have the arrays which are storing that the previous smaller and next smaller is present at which index, like 4, 0, 1, 2, 3, 4. For 2, the smaller variable is present is at index -1. For 1, that is -1. For 5, it should be present at 1. For 6, it should be present at 1, not 2, because 5 is smaller. And for 2, 1 is smaller, that is present at 1. For 5, this 3 smaller is present at 4th position. The next smaller element, 3's next smaller element is nothing, so its index should be 6. 2's next smaller is nothing, 6. 6 next smaller is 2, that is 4, 4th position. 5 next smaller is 2, that is at 4th position. 1 next smaller is nothing, so it is 6th position. And 2's next smaller is 1, that is at 1 position. So suppose we have already given this, how we would be calculating the maximum area, like iterating through this histogram. It's having height of 2. If I am having height of 2 and width, how can I calculate the width? I've told you the next smaller element is present at -1, sorry, 1. So 1 minus previous smaller element is present at -1. 1 minus -1 would be the width of it. So 2 into 1 plus 1 minus 1, that is 2. The area would be 2. For 1, the lesser element is present at -1, the greater element is present at 6. So 1 into 6 minus -1, 6 minus -1, -1. So 1 into 6 plus 1 minus 1, it would be 6, right? Similarly, for this 5, the previous smaller element is present at 1 and next smaller element is present at 4. So 5 into 4 minus 1, 4 minus 1 minus 1, it would be the width. So 5 into 2, that is 10, right? Similarly for 6, the left smaller element is present at 2 and right at 4. 4 minus 2 minus 1 would be the width. So the width is 4 minus 3, 1, and the height is 6. So the area would be 6. Similarly, we will calculate for every bar, and the maximum area we could get is 10, right? So this is how we can calculate the rectangle with the maximum area, right? Here we are going to calculate the previous smaller element for each element, right? So suppose we are having a stack. Right? For 3 there is no previous element, so we can call it as -1 as the previous smaller element, right? Just push 3 into the stack. Now see that 4 2 C2, and we have 3 into the stack, so that at the top of stack we have 3 which is greater than 2. So just pop this 3 out and push 2 into it, and there was no element which is smaller than 2, so we can write it as -1. Now 2. Now we can come up at 10. Compare it with the stack's top. 2 is the lesser element, so for 10 2 is the lesser element. Okay, just push 10 into the stack. For 11, if I compare it with the stack top element, I have 10. So for 11, 10 is the left smallest element. For 5, I can see that 10 is not the greater smaller element, so pop it out. I compare with 2, 2 is the lesser element, so I can do it 2. For 10, if I compare with stack top, 2 is the lesser element. No, but I need to push 5 first, right? Now I need to compare 10, compare with stack top 5. 5 is less element. Now push 10 into it. Compare it with 6. Is 10 lesser than 6? No, pop it out. Is 5 lesser than 6? Yes. Write it. And push 6 into it. For 3, do we have any lesser element at the top? No, pop it out. 5 is lesser than 3? No, pop it out. 2 is lesser than 3? Yes. So 2 is less than 3. So here we get the element which is lesser than any element to the left of it. Here we can see that 3 has no element which is lesser than 3. So -1, 2 does not have, 10 does have, which is 2. We have stored it. For 11, we have 10, which is we have stored. For 5, 2 is the lesser element to the left, that is we have stored. For 10, we have 5, we have stored. For 6, we have 2. No, for 6, we have 10. So we have 5, we have stored. For 3, we have 2, we have stored. But in our case, we don't need the values of the smaller element. In our case, we need the position, right? So instead of pushing values into the stack, we could just push position of the values. Let's have it. Let's go. We are having a stack, right? For 3, there is nothing into the stack, so the position of left value which is lesser than 3 should be -1. So we do it -1 and push, not pushing the 3, we would push 0 into the stack. Okay, Now 2. Compare 2 with a double r of 0. If I compare a double r of 0, that is 3, which is greater than 2, so pop 0. Okay, now push. Now there is nothing into the stack, so the position should be -1 for 2, and we push the 2 position here, that is 1, 2's position, right? Now compare 10 with a double r of 1. When we compare 10 with a double r of 1, that is 2. 2 is lesser than 10. That's why 10 here we will do its position is 1. So we will set it to 1. Now we can push its position, 10 position, which is 2. Okay. We're doing the same thing, but here we were pushing the element. Here we are pushing the position of the element. Okay. Similarly, for 11. Now compare 11 with element as position 2. I compared 10 with 11. 10 is the lesser element. That's why I would put 2 here. 2 position, and I'll push this into the stack. I pushed it. Now if I compare 5 with the element as position 3, which is 11. 11 is not lesser than 5, so pop it out. Now compare 5 with element at position 2, that is 10. It's not lesser, pop it out. At position 1 we have 2, so 2 is lesser. Similarly, we can calculate the next smaller element by iterating from the back. It up, and n should be a double r dot size, the number of elements, and we should have the previous and next smaller elements as stored. So it should be vector of end of previous with size n and next with size n. Now we will calculate this previous and next elements. So just iterate through the array for n I less than n, I plus plus, and we should have stack for that. Stack and st, and while stack is not empty, not st dot empty, and a double r of st dot top is greater than a double r of I, right? We will do st dot pop. We'll pop the elements. Now I'll find the index, which is if st dot empty, if stack is empty, then the index would be -1, else the index would be st dot top. We assign the index to previous of I should be index, and we would push the index into the stack, and we will calculate the next also. Before it, let's just pop the elements from the stack. While not st dot empty, st dot pop, and we will do the same for here, but from the last. We will iterate from the last, and I is equal to n minus 1, I greater than equal to 0, I minus minus, and while st is not empty, we will pop it out, and it should be greater than equal to a double r of I and index would be n, otherwise st.top. Next index would be index st.push. That's great. Now we will calculate the maximum area. So let's initialize the answer as 0. Let's iterate I is equal to 0, I less than n, I plus plus. Now what's the width? Int width we have calculated is, it should be next of I minus previous of I minus 1, right? And the area would be a double r of I, which is height, into the width, right? So answer should be maximum of area and itself, and here we should return our answer. So the answer would be answer. Let's run it. Yeah, we have found it is the right answer. Let's just submit it up. Yeah, it's the correct code. So thank you so much for watching.